In earlier video tutorials, we've seen how we can go about selecting engineering materials according to material properties or material performance requirements. We've also seen how the different manufacturing processes available for different material categories could also influence the selected material for a given component or application. In this video tutorial, we're going to look at some additional considerations relating to material selection. In particular, we're going to talk about product design requirements. We're going to consider environmental and sustainability considerations. And then we're going to talk about a concept called the circular economy concept. So as part of the product design process, an engineer would typically produce a product design specification. Now, the product design specification would specify various different aspects of the design, which would obviously influence the materials being used for that product or components within that product. Now, a product design specification could have lots of different categories depending on the application, and could range from a very simple product design specification to a very complex product design specification. So some of the things that might be included are things such as material properties. Now, we've already seen how we can select materials according to their material properties, but some of the other requirements might be things such as aesthetics. The design engineer may specify the colour or the surface finish of components, and then you'd obviously have to consider things such as the manufacturing processes and the finishing processes in order to achieve those requirements. The design engineer may even specify which manufacturing processes need to be used. Certain processes may need to be used to minimise waste, as an example, and they may also specify finishing processes to achieve certain surface finishes or protective coatings on the components. So all of these factors would need to be taken into consideration. We'd also need to consider the general performance of the component. Where's it going to be used? How's it going to be used? How does the end user interact with that component or that product? Depending on the application, the design engineer may specify how it's going to be installed, how it's going to be commissioned, and how it's going to be operated and maintained. All of these things could potentially be included in a product design specification, and at the end of the design process, the designed product would be measured against the product design specification to ensure that all of these criteria had been met. Another consideration might be availability of materials, or availability of built-in components, or even availability of manufacturing processes. So are there companies that can manufacture these components or products in a timely manner in order to achieve the desired result within a specified timescale? Now, further to this, we might have considerations such as life expectancy of the product, shelf life of the product, and any maintenance schedule that needs to be adhered to in order to maximise the life expectancy for the component or product. Now, another important consideration is any relevant legislation to ensure the component can be used safely, or any standards, such as international standards or British standards, that should be adhered to during the design. The important point to note from this is there's lots and lots of factors that need to be considered during material selection, and many of these would be specified in a product design specification to ensure all of those criteria were being met. So, in addition to product design requirements, we also have environmental and sustainability considerations. It should come as no surprise that reserves of various raw materials are depleting, and if we continue to use them in the way that we're currently using them, they may even run out. We certainly know this to be the case with things such as coal and gas, which would often be used during various manufacturing processes to produce our components. But those aren't the only raw materials that are available in limited supply. We're also hugely concerned with the environmental impact associated with the production and use of various different products. Are they harmful or toxic to the environment? Are they hazardous to human health? Now, sometimes this can't be avoided, but it's another important consideration during the material selection process. As an example, hydraulic fluids are known to have various different impacts on the environment, and we're seeing a shift away from traditional hydraulic fluids in various industries to organic or less environmentally harmful fluids that can fulfill the same application. Another huge consideration is the recyclability of components. Is a product going to end up in landfill at the end of its working life, Or can it be stripped down so that the materials can be reused for different applications? Now, I mentioned previously about the depletion of coal and gas, and this feeds directly into the energy usage throughout the life cycle of a component. We're looking for ways to reduce the amount of energy used in production, but we're also looking for ways to reduce the amount of energy used during the use of various different products. Take lighting, for example. We've seen a shift away from the typical 40 or 60 watt light bulbs to LEDs, which would typically consume 3 to 5 watts as an example. And there's lots of different examples through lots of different industries and sectors to demonstrate that fact. Now, this all leads us on to something called the circular economy concept. Now, the circular economy concept is a model of production and consumption. So traditionally, we had a linear economy where raw materials would be used to produce a component, and then that component would be discarded or end up in landfill at the end of its working life. But we're seeing a shift away from that and into something called a circular economy. Now, the circular economy concept is based on reusing, repairing, refurbishing and recycling materials and products. And we'll see an illustration of this in a moment. The purpose of this circular economy concept is to extend the life cycle of products and components, whilst also looking at reducing waste and pollution. So it's a means of minimising the environmental and ecological impact. So the graphic we see here is from the European Parliament Research Service, and it shows an illustration of the circular economy model. If we start in the top left-hand corner, we have our raw materials. But feeding into the process, we don't have only raw materials, we also have any recycled materials exiting the other end of the cycle. So we have a mixture of our raw materials and our recycled materials. Part of this model is around sustainable design. Now, earlier we talked about the Product Design Specification, which specifies the requirements for the design of a product. And here we're reinforcing the fact that even at the design stage, we need to be considering what materials are going to be used and the impact that they may have on the environment. For example, are we going to select recyclable materials? Are we going to select materials which require less energy for processing? We then move to the production stage, and once again during the production stage we'll be looking to minimise the amount of energy used as an example, but we'll also be looking to minimise the amount of pollution, and much of this will be driven by legislation relating to the use of energy in CO2 emissions. We need to consider distribution. What is the impact on the environment of the distribution methods that are being used? Now, once the component or product reaches the consumer, we have the consumption, reuse and repair stage. We're seeing many trends in things such as upcycling, as well as donating products that we've finished with. Now, that's on an individual level, but we're also seeing similar things within business. If something becomes damaged, do we just discard it? Or do we find methods to repair a product? Alternatively, can we reuse elements of that product and recycle anything that we can't reuse? Okay, next we have collection of any redundant items, but once again, that damaged or redundant component or product isn't just going to residual waste where it would end up in landfill. As much of that product as possible is either being reused or recycled. So it may be possible to rework the materials so that they can then be used alongside raw materials to manufacture new components or new products. So alongside the performance and behaviour of materials, we also have these considerations which relate more directly to environmental impact and sustainability. So just to summarise then, in this video tutorial we've talked about product design requirements, which would often be communicated through a product design specification. We've discussed environmental and sustainability considerations, which would also influence material selection. And finally, we've talked about the circular economy concept and the importance of reusing and recycling wherever possible. Now, the other important point to note here in summary is that the environmental and sustainability considerations that we've spoken about and the circular economy concept are also going to feed directly into the product design requirements or the product design specification. Product design specifications can specify the types of materials that can be used, and they can also specify what happens to components or products at the end of their life cycle. So the product design specification itself plays a key role in driving forward these sustainability and environmental issues.